using properties of equality to solve equations. A balance scale shows that the weight on the left side of the scale equals the weight on the right side of the scale. We can use this idea to help us understand how equations need to be balanced. Whatever operation we perform on the left side of an equation, we also perform on the right side of the equation. We do this to maintain a balanced equation. For a full description of how this works, please view the video Balanced Equations. But the basic idea is that we choose the operation, addition, subtraction, multiplication, or division, that will help us isolate the variable on one side of a balanced scale or equal sign. We must perform this operation on both sides of the balanced scale or equal sign. By performing the same operation on both sides of an equation, we preserve the balance or the equality of the equation. Look at the table here. There are 4 properties of equality we can use to manipulate equations. If A equals B, then A plus C equals B plus C. In other words, we can add C to both sides of the equation and it is still equal. The same holds true for the other 3 operations. We can subtract C, multiply C, or divide C, as long as we do the same operation on both sides of the equation. Both sides will then remain equal and the equation is still in balance. Let's look at our first example. After spending $2.30, Rondell had $5.70. How much money did he have before he spent $2.30? Our equation, x minus 230 equals 570. Let's do the steps and then check our work. We see that 230 is subtracted from x. To isolate x, we add 230 to the left side of the equation to undo the subtraction. We add 230 to the right side of the equation to keep the equation balanced. The result is a simpler equivalent equation. We find that Rondell had $8. To check our answer, we substitute $8 for x in the equation. $8 minus 230 equals 570. Since both sides of the equation equal 570, the solution is correct. Let's look at example 2. If a 12-month subscription to a magazine costs $8.40, what is the average cost per month? We'll use the equation 12m equals 840. The variable is multiplied by 12. To isolate the variable, we divide the left side by 12. 12m divided by 12. This is 1. And to keep the equation balanced, we divide the right side by 12. Our answer is 1m equals 0.70, or simplified further, m equals 0.70. Now we need to go back and look at the context of our problem. What does m equals 70 mean? We were looking for the average cost per month. So the average cost per month for the subscription is 70 cents. Now let's check our answer. We check by substituting 0.70 for m. Here's our original equation, 12m equals 8.840. We substitute 0.70 for the m, and now we have 12 times 0.70 equals 840. When we simplify, we see that 840 is on both sides of our equal sign, our equation is balanced, and our answer is correct. In this example, we will solve the equation 2/3 W equals 3/4. W is our variable which we want to isolate on one side of the equal sign. The variable W is multiplied by 2/3. So we can use the inverse operation and divide both sides of the equation by 2/3. Recall, however, that dividing by 2/3 is the same as multiplying by 3/2. It's reciprocal. To keep the equation balanced, we must also multiply the right side of the equation by 3/2. Recall also that the product of a fraction and its reciprocal is 1. We can prove that right here by multiplying these two fractions. 3 times 2 is 6. 2 times 3 is 6. 6 over 6 equals 1. So this equals 1W. And we multiply the other side of the equation by 3/2 as well. 3 times 3 is 9. 2 times 4 is 8. So 1W equals 9/8, or simplified even further, W equals 9/8. We check our problem by inserting our answer in the place where the variable is. So we substitute our answer for the variable. We can rewrite the problem then as 2/3 times 9/8, and then we can use some canceling to simplify our problem. 3 and 9 are both divisible by 3. 3 divided by 3 is 1. 9 divided by 3 is 3. 2 and 8 are both divisible by 2. 2 divided by 2 is 1. 8 divided by 2 is 4. Our answer is 3/4. Our equation is balanced, so our answer was correct.